chair and I was starting to sweat because I'm not going to be the presenter that keeps you from that fishing tournament. So I figured we would keep this thing going. Very happy to be here. Never been. Amazing. I mean, this place is absolutely gorgeous. So thank you, Bob, and thank you for everyone coming. Today what we want to talk about is a little bit about fish nutrition in terms of the bioenergetic needs of the fish, and we can relate that into pond dynamics, food webs, wherever you guys want to go. I know I have a fancy title, but I'm just a Midwestern boy that couldn't stay at a pond. Love mucking around, love getting my hands on fish. I went to Iowa State. I was going to get into fisheries management. Then I met Joe Morris. I don't know if anyone knows Joe Morris, and he convinced me that pond management was something that was a little bit more for my professional skill set, getting out there, working with people, understanding their ecosystems and doing management. But there's something about hands-on fish that kind of led me into reproductive physiology, where I was working with the white bass and looking at how the bioenergetics of the female can deliver that nutrition into the egg. So just a simple Midwestern fish nutritionist, I guess. I do have the pleasure to work with a great team of nutritionists that every day we get to wake up and think about different solutions that we can provide. We do have a global business. We have a lot of different offerings. We work with several of you in the room, and my job today is to learn more about your needs and see what different types of solutions that we can create in terms of ingredients, the purveyors of those nutrients, as well as specialized or customized feeds to meet your need. Would you advance the slide, please? So if you look at our approach, Cargill has an extensive ingredient library. You know, we're involved with a lot of the different commodities, so there's an extensive understanding of the ingredients that are within that library. But today we're going to talk about that not all ingredients are created equal. There's a lot of nutrient variability. I'm going to say nutrient a lot, and what I mean there is that's the nutritional compounds, you know, the sugars, the protein, the fat, you know, the vitamins and minerals, and all ingredients. Those nutrients within a fish meal or a poultry byproduct meal, soybean, even corn, DDGs, you make the list, they all share different components. If we have a good understanding of that variation, then we can make real decisions to what we do in the feeds. But the other thing that Cargill does, and we'll go through this pretty extensively, we like to have our hands on those fish to see how they react to those nutrients. Right? Just like managing our own cholesterol or blood sugar, we want to make sure that we know the nutrients that we're targeting in there for uniform growth of fingerlings, as well as delivering maximum fecundity of a female that she can experience through her lifetime. We want to make sure that we understand the nutrient demand. But the value that we can deliver in a lot of different situations is taking those two approaches and having them work in concert. So once we identify the nutrient demand of the animal, then we can go back into that ingredient library. We can select the right ingredients to go into the feeds to get into the animal. And I'd like to emphasize that point. We want those nutrients to stay in that animal because any of the waste, nitrogen, phosphorus, potassium, etc., that's going to hurt our aquatic food web in the terms of increased nutrients, and that may not be a good thing for us. Next slide. So, this is not death by PowerPoint. I promised Bob that we'd make this very interactive. I used to be a research professor down in Southern Illinois working with Chris Kohler, Roy Heidegger, and a number of those guys. So I still have that little bit of professor, so I have a lot of questions. First question, how many ingredients do you see up here? Sorry, right in your way.
Huh. More than 9.
More than 9? One? Well, this man has the right answer. It's one ingredient. Bob, if you want to advance the slide. This is corn distillers. But the true question, the trick question, is which one is the best quality and why? If you had to make an emotional decision that you're going to buy an ingredient to go into your feed and you saw these, which one would you pick? And why would you do it?
Not enough information at all.
Well, let's say you had to make an emotional decision.
The dark one,
The dark one. Why? Why the dark one?
because you want your fish food to be dark.
Do we want our fish food to be
How
dark?
about the light one?
How about the light one?
Because the dark one has probably been roasted and some of those components have been altered due to the heat.
Yeah, like a Maillard reaction. So the amino acids react with the sugar. You get that browning effect, and the further you go, you get that black, right? So now we have two spectrum. We have some people that like that brown ingredient, and some up here said, well, you know what? That looks fresh. That looks like something that, you know, that could do some good for us, right? Historically, nutritionists have done this. But in our approach, we don't want to make those, and I know I put you guys on the spot for the emotional decision. And the answer is there's no right answer, right? So, but what we want to do is we want to get away from those emotional decisions in the ingredients we select and select the right ingredients that have the right nutritional profile. So this is the job of our team in Cargill up in Elk River. We'll show that. We spend a lot of time looking at the ingredients, each one of those within Cargill's ingredient library, to see what the variation is and what will be the best ingredient to select for our either to sell the ingredients out into the aquatic industry or to put it into our own feeds and feeding programs. Next slide. So just want to recap this really quickly. So a lot of people in the industry have an ingredient mindset. The first thing they ask, well, how much fish meal is in the feed? How much soybean is in the feed? How much poultry byproduct? How much blood meal? Etc., etc. At Cargill, we focus more on the nutrients. Well, how much starch can that largemouth bass have before it starts depositing a lot of belly fat, right? So when an angler goes out there and he cuts open a fish, there's a number of different things that he has on his mind. Better have the right color, better not smell, right? I mean, and when it gets into the gastrointestinal, they want to make sure that, you know, maybe they can't classify out all of the organs, but they know if there's a lot of fat in there or there's a lot of trouble, they're going to know something that's happening. So those nutrients are within all of the ingredients. So we focus more on delivering the right nutrition through those ingredients. It may seem like a very small difference, you know, in between a nutrient or the ingredient that has the nutrients, but the nutrients are the ones that drive animal performance. If we can deliver consistent nutrients to the animal, we can get predictable results, right? We can demonstrate this in laboratories, and we certainly can demonstrate this in the field. Next slide, please. So just to go through this concept a little bit more, you know, if you look at ingredients, especially the plant proteins, you think that would be pretty stable. Corn's corn, soy's soy. But depending on the genetics, the variety, the amount of moisture that's there, the soil type, and how it's processed, you can get different digestibility of the protein. You can get oxidation of the fat. So we looked at one supplier over time in the Midwest. On the top graph, that's protein. So soybean has anywhere from 46 up to 52% crude protein. But you can see over time from one supplier using one process, we're getting a lot of variation. And if you're formulating to a soybean that you think has high protein, but it actually is coming in low, then you may have troubles with how the fish responds to that. Even more importantly is the bottom graph. This shows the level of fat that's within the soybean. Very directly related to the moisture. So energy of the feed, if you're looking at any feed, the energy is coming from all of the components, but the most accessible source of energy to drive anything that you're trying to target is going to be coming from that fat. So we want to make sure that we have a good understanding of that variation as well.
Is that raw bean meal?
No, this is standard processed soybean meal.
Okay.
Next slide, please. But even more importantly, especially to the aquatic species, we're going to talk a lot about this today, and we'll keep it within a reasonable amount of time. Carnivorous animals like largemouth bass, walleye, etc., they want to have the right feed effectors and define a feed effector's attractants, getting the fish to know to eat it, and then the palatants, so once they consume the food, it has the right taste. How many people have seen a fish spit out a fish pellet before? You ever seen that? Right? Then boom, they hit it immediately and they're like, no, I don't like that, and they'll spit it right out.
It could be texture also.
It could be texture also, that's correct. But sometimes they're not used to the palatants of the feed. It could be related to the texture, as you said, the dryness. So some people may use different compounds in there to make a softer feed. So like with a tuna nugget, you know, that's an inch long, we may add things that will make sure that the texture is soft. But in fish meal, it does contain a lot of those feed effectors, right? So the attractants, the palatants, to make our highly carnivorous animals accept the food. But fish meal is one of the nastiest ingredients to work with, because think about it. You're on a boat, you catch a fish, you let it sit on the deck, you drive a couple miles back into shore, right? You know that fish is going to start breaking down. Then it goes into the processing. Depending on the level of heat, you know, there's a lot of quality issues you have. And the nutritional components of the fish meal are not the same between a herring, a menhaden, a sardine, or another clupeidae. So, test questions for you. So this is one supplier looking at one fish species. It was sardine over time. This is crude protein. Sorry if you can't see it. It's going up to 72% and down to 58% crude protein. If you were selecting your fish meal, would you select a fish meal with high protein or low protein? High. Of course, high. Right? Fish meal is very expensive. You want to make sure that you're getting those amino acids and the protein to your animals. On the next slide, using our technology, we looked at the digestibility of the protein. Oh, Bob came back there for me. We looked at the digestibility of the protein of the incoming fish meals. So now we have the total protein content of the fish meal and the digestibility of the fish meal. What did we find? Some of the highest protein containing fish meals had the lowest digestibility. Any guesses why? That's a trick. I mean, that's a tough. Why would something that has such high crude protein, and it's not adulteration with melamine or anything like that, why would a fish meal with such high protein have such low digestibility for the fish?
Processing.
Exactly right. So what the fish meal supplier was doing is they know that they can get a premium for their fish meal if they get more moisture out, right? You take that moisture out, you can elevate the protein. But if you overcook the protein, it actually denatures, rendering it undigestible to the animal. So this was a huge eye-opener to us, because a lot of people in the industry, you know, when you look at different fish meals, the select fish meals or high-quality fish meal actually could have a lower digestibility on how it's being processed. Because what they're doing is they're putting just a little bit more energy in that fish meal to blow off the moisture, and then they can command a higher price on the fish meal. But for us as managers and biologists, this is not a good thing, because if the nitrogen and the protein doesn't stay in the fish, where does it go? It's going to go right into the water, right? And then we have to make different decisions in how we manage any given body of water. Next slide. So just a high-level overview of a little bit of our approach. We're going to take a little bit deeper dive. I'd like to invite you all up to Elk River, Minnesota. We raise a lot of different fish up in our facility up there. We had to take this picture during the summertime because if it was winter, it'd just be white with all the snow. But Bob's been up there. He spent a little bit of time getting to understand our systems. And we like to bring everybody in because we'll take a whole tour of the farm, and you'll be able to see that not only can we learn from other animals and how they assimilate nutrients, we actually can contribute back to livestock as well. I mean, if you look at fish nutrition, fish nutrition in general, we're the masters of the omega-3 fatty acids, right? And the other species are trying to catch up to us. But even more important than the other animal units is the laboratory, right? So we have our aquaculture facility, we have animals on site. I mean, right now we have major studies going on with the largemouth bass, which is that extreme carnivore and very particular, right? So it looks at the food, it looks at its brother. I don't like that, I'm gonna eat you. So it's a good model for us to work with. We have a lot, please come up and see it. But having the laboratory there, we can scan all of our ingredients, so when we formulate the feeds, we know exactly the nutritional quality that's going in there. So invite any of you to come up. Feel free to work with Willie and Dave. I like talking about fish, so it'll be good. Grass won't grow between my toes. Next slide, please. So there we have 80 full-time employees that are managing the animals 365 days a year. We have 15 nutritionists on staff. We just picked up Dr. Heidi Hill. She was with the Fish and Wildlife Service out in Washington. We're very happy to have her there. Very strong background. She's actually from here, from Missouri. She asked if she could come down, but it was too late. I'm not going to tell her how nice it was. The animal units we do have an aquaculture unit. So this is our fisheries biology laboratory. Then we also have beef, dairy, pork, and poultry. Enabling teams are very important. Processing, right? So the people that can take the ideas from the scientists and make sure that when it goes into the right feed form, the animals are going to get the nutrients in the way that we want them to receive it. There's a lot of specialized technology that we have developed for the aquaculture industry over the last 30 years. Been working with David and Willie and a couple of biologists here. We think that we can transfer some of that processing knowledge over because we have a lot more to offer than just those extruded nuggets. We can talk more about that offline. Our laboratory development, these are the people that are monitoring both how the animals are receiving the nutrients, right, the nutrient demand, as well as what are in the ingredients. Every year that corn crop and soybean crop changes slightly. But again, even more important to us are those animal byproducts, including fish meal, because those have the right feed effectors, right? So until we can identify all of the feed factors that are coming out of fish meal, as well as the animal proteins, right, we need to make sure that we have a good understanding of the animal proteins going in there. And last but not least is the formulation innovation team. One of the reasons I left the university is I was publishing a lot of different papers and I was noticing they were going straight into the library, right? I didn't have a good understanding of how much was actually being applied in the field. But by coming to Cargill, it no longer sits on the shelf. We can get it directly into application to deliver value immediately. And that's what the formulation innovation team does. They'll capture ideas from scientists, they'll put it into software, and then we can distribute it out. It could be models, different modeling techniques that you have, or it could simply be formulation nutrition. Excellent. So we have a lot of different animal models that we work with. Here in the United States, we formulate feeds for at least 10 different species, including sport fish and aquaculture. Our prime models but we can't work with all of them at a given time. So we select the animals by their nutritional physiology, right? So we cluster the carnivores, the omnivores, and we really don't work with any herbivorous fish here. So you have a number of different species. And again, right now our top carnivore that we're using is the largemouth bass because it seems to be a little bit more sensitive than the striped bass as well as the hybrid striped bass. So what we want to do is we want to identify the beneficial nutrients that obviously get the animals to eat the feed, put on the weight, especially in the smaller sizes, right at the onset of exogenous feeding, up to a small fingerling, we want to make sure that we get them up fast, high survival, and have the same size uniformity. The reason that we want to do that is when you look at your fisheries population dynamics, if you're targeting high heterozygosity with any of your any of your genetic pools, you want to make sure that all of those genes are going to be available. If not, if you're selecting the animals at a young phase, you're actually selecting for different characteristics. So what we want to make sure is that we get all of the animals up, high survival and high uniformity, and we can maintain that heterozygosity in the population. Improved stress tolerance and survival. Animals in water, given any season, are constantly under stress. Temperature, dissolved oxygen, nitrogen cycles, pH, and all of the interactions in between. But if we can find the compounds that really put them in good health status, and I'll give an example of what good health status means, we can keep healthy populations moving ahead. And then obviously we want to reduce our ingredient dependencies. Fish meal is a finite resource, natural resource. It's only about 5 to 7 million metric tons of fish meal being produced annually. We're going to go through that. But what we want to do is the more nutrients we can identify in fish meal, we can develop more alternatives. This will make us more eco-friendly, and then obviously a little bit, I guess, not using fish meal just to use fish meal to get them to eat it, but what we can do is we can better manage that resource. Next slide, please. So, I'm sure you've all seen this in the past. Not all fish are created equally. I mean, if you cut open my favorite, which is a panfish, you can see the pyloric ceca, and when you cut open the largemouth bass is much different than if you cut open a grass carp. Right? Grass carp has a very unique intestine. I mean, we're using it to take out the aquatic macrophytes, and it has the nutritional physiology to break down those carbohydrates. Conversely, the largemouth bass is the lion of the sea, right? It's not looking for a salad. It wants highly digestible meat products, or plant if you can make them. So depending on what their physiology is, then you can understand how they can receive those nutrients and how it will impact their growth, their survival, and their reproduction. Bob, next slide, please. Any questions so far? Okay, so when we talk about good gut status, right here what we did is just took a cross section. This is a histology slide, and in the fish what we did is a number of different treatments, looking at some ingredients that we know have no high carbohydrate content, and you can see here in the gut. So this is just a cross section. You have the microvilli, kind of like your fingers. We want those fingers nice and strong because then those fingers can pull out the nutrients. If you get acute necrotic enteritis like what we have on the right-hand side, those fingers are breaking down, right? There's a lot of scar tissue that's in there. You're making the fish not in the best status to receive those nutrients. A fish in this condition usually does not want to eat, right? Their intake will go down. You'll see that they still will eat, but they're not in the best health condition. If you take an indirect effect or an indirect stressor, right, of temperature, pond turnover, or some stress, this guy is going to be hurting, right, because he's not taking out the nutrients that is going to help him through that stress period. So what we target on is making sure that those villi are nice and strong. And we're providing nutrients that the animals can have. And there's nutrients here that actually can fix the microvilli and make it strong. Just because a condition's like that, the fish, the cell turnover is so quick, if you have the right nutrients in there, you can rebuild quickly. But if you're in this condition and you have the right compounds, you actually can help the animals through that stress period. So when we talk about health status, we're trying to make sure that the fish has really good gut integrity. Those microvilli are nice and strong, and they can take out the nutrients. So in that, this is just fancy graphs, it's pretty basic stuff. When we look at carbohydrates, we want to look at to see what energy they can actually get out of the carbohydrate. Since the largemouth bass intestine is so short, they don't have a lot of time to get energy out of carbohydrates. Plus, they really don't have the enzymes to break it down. So what we can do is we can look at carbohydrates, the impacts on nutrient availability. There's actually some carbohydrates that will erode protein, and then it'll fly through the fish. So we want to make sure we have an understanding of that. Looking at different enzymes that we could potentially put in the feed to help the animal break down the feed. But some of the fiber degrade. You never want to put in an enzyme in a feed because then a lot of things can happen. Maybe the fish can't utilize that enzyme. So at Cargill, what we do is we go upstream, we take those ingredients, we pre-digest them, and then we can put it in. Much better form, and you get much better results with that. And then, of course, we're developing new ingredients. I don't know if any in here are familiar with ingredients, but Imperial 75 is one of the ingredients we developed in our laboratory that's going out to all of the aquatic sciences. That's available in a number of different other ingredients that we're continuing to offer. We want to make sure that, you know, the hatcheries that we're working with, state and federal, everyone is going to be sustainable and having the right products going in. Additive screening, you might hear about probiotics and prebiotics if you watch the yogurt commercials. We look at those two. Botanicals, everyone's trying to switch to oregano, garlic. I mean, you name it. We test those to see how the gut bugs react. And those are gut bugs that are actually coming out of a fish. Which is interesting, not to bore you with gut bugs, but a fish gut bug, the same species from a pig or a pork, is completely unique. So for the microbiologist, it's always interesting to look at the fish gut microbiota because it's so unique. And then last but not least is looking at the nucleotides and their bases. This is looking at improved intake, but it also is in RNA synthesis. So when you look at those microvilli and they're busted up, the nucleotide, specifically their bases, can come in and they can rebuild that foundation for strong microvilli. Next slide. Okay, next slide. Just want to talk a little bit about, you know, fish meal. Everyone hear about the fish meal issue that's going on? You hear a little bit about this in sustainability. So just wanted to show you some data. In 1960, if we look at the available fish meal, 50% was going to pork and about 50% was going to poultry. Fast forward to 2008, you can see 69% of the fish meal is now going into aquaculture feeds. 69%. Anyone know, if you look at global livestock, how much aquaculture feed and sport fisheries feed there is relative to others? Any guesses? 10%. 10%, an industry that's only 10% of the total is commanding 60% of the fish meal, right? There is an issue, and we have to intervene and find solutions to make sure that if we're going to be supporting sport fisheries and even the aquaculture industry, there's got to be solutions in this space. Next slide. Even more alarming is fish oil. So if we look back in 1970, you can see the industrial application. But if you fast forward to 2010, you can see 80% of the fish oil that's available is going into the fish sector. But most concerning is that 12% refined fish oil. Any guesses what that industry is?
Little bitty caps that we take down our gullet.
Exactly. Little bitty capsules that we pay top dollar for, right? So where are we going to get our EPA and DHA from? Well, the nice thing with biofuels, as they were looking at algae, I don't know if algae is going to be an effective biofuel or not, but it's a great alternative to get those fatty acids, right? So they're scaling that up. It's not as big a scare with fish oil as what it was previously. There are some fermented products that are available, but when we put this data together, we were like, wow, right? We need to find some sustainable solutions immediately, because you might ask, well, what does EPA and DHA really mean for a fish? Well, in temperate climates where you have seasons, you don't want, let's think Crisco and vegetable oil, right? And Crisco is the fats that are everything but EPA and DHA, and the vegetable oil is EPA and DHA. As you cool those animals down, you do not want them to turn into Crisco, right? You want to make sure that they have that membrane fluidity. So this is the importance of EPA and DHA, because in cold temperatures, they keep those metabolic processes moving. Next slide. So we talk about fish meal replacement and developing, ingredients for the sport fish industry. We got to break everything down. There's a lot of compounds in here. You have your fats, your proteins, your specialized fats, and some of your specialized nutrient compounds. Biogenic amines are breakdown products, so we're not so interested in making those. But the key is, once we can identify those nutrients, we can manage that by going back into our nutrient stream. Next slide. So if you look at fish meal replacement, fish are very interesting beasts. I remember one graduate student down at Southern Illinois University had to start over because this one graduate student who didn't end up finishing was throwing, in a feed trial, is actually throwing in chicken McNuggets to the fish. Right? They're supposed to be on a specialized, but he's throwing, and they're like, why are you doing that? They're like, I didn't think they were going to eat it. Right? So, it's very interesting when you do feeding behaviors, because successful fish meal replacement, you could balance amino acids, fatty acids, the whole gambit. But if the fish doesn't recognize it as food, it hits it on its head and it goes to the bottom of the pond, right? You really haven't done your job. So we have a very disciplined process to understand these compounds. So as we go through, we look at the feed effectors. Just have a little graph here. This is looking at preference. So how many times the animals prefer the feed. In the green, that's the control. That's fish meal. Right, so you can see they like that. Then if you look at the bottom, that's formulating to all of the known nutrients without fish meal. You can see you're not getting it. And then when you look at different compounds and different compounds in combination, you really can get those fish to, not only be attracted to it, but to eat it. Now, because of this research, Bob banned me from the fishing tournament today. Next slide. Next slide, please. So, but the true test is looking at, right here what we have, these are about 20 to 25 pound redfish. Redfish are very sensitive. They have a lot of chemoreception in there. So they're wild animals, and we're actually throwing them, it's not a tuna ration, but it's actually a test ration for these animals. But you can see, when you balance the right nutrition, you can get wild animals that have never seen a feed object presented to them. They'll go after it pretty readily. So feed effector is really key in developing some successful products when it comes to wild fish and really young fish. Next slide. So just want to talk about some of the offerings that we have. I'll wrap it up here within the next couple of minutes. Next slide. So when you look at the nutrient demand, this just kind of highlights what we have. We have a number of different systems that are designed specifically for fish. We can leverage those systems to customize any feed products to target any market target that you have. If it could be the fingerlings, bring them up a uniform size, increasing the survival, there's different manipulations we can do. All the way down. Right now, we do have solutions in terms of products for the industry on fish meal replacement. Right now, they're not available to the industry. Some of the components like Imperial and others are. But what we're looking is just to give an option for everyone, if they choose, to eliminate fish meal and or fish oil in their feeds. And most importantly, probably for this group, I see that there's a number of different people that are going to talk about it. And I think in the first presentation was alluding to it, right? If you have a bottom-down approach, we want to make sure that the feed stays in the fish population and it's not getting into that pond. Because then that's really when we have to kick it up as managers and do a lot more work. Next slide. And then this is just managing the ingredient supply. You know, we have a very systematic process and technologies to manage the incoming nutrients that are going into the plant, utilizing those capabilities and delivering the consistent nutrition. This is very important because what we don't want to hear is, well, the feed worked in April and now it's June, it's not working. So we want to make sure that the nutrients that we targeted, that we've customized, are being delivered. Next slide. So the available products, if you're really looking at targeted nutrition, these are the two lines that David and Willie are managing. We also have this Sportsman's Choice Trophy Fish Feed, as well as the Catfish Floating Feeds. Those are more general, that are available to the public. And then I have the big question mark. My objective is to learn from you, you know, over the next couple of days. What can we do? What is the next Sportsman's Choice going to be, or what is that next targeted, you know, production feed or pond feed that you're looking for? What does it look like, and what do we need to do to make it a success for you? Next slide. With that, I know that is a lot of information very quickly. Thank you for your attention, and we'll entertain any questions you may have. Ken?
So there's a myth perpetuated by the wild salmon industry in Alaska suggesting that wild fish are better for you than farm-raised fish because of the contamination of PCB, mercury, and dioxin.
Yeah.
And how can you address that question, specifically screening for those contaminants within your feed ingredients?
Yep. There's several components within that. May I ask a question to answer your question? Sure. What do you think? What are your thoughts on that?
I think it's an industry that's trying to limit aquaculture production in the state of Alaska, and so they're spreading myths that aren't necessarily based on science.
Yep.
And specifically, I think most quality feed companies screen for those contaminants.
Yep.
From the medical standpoint, the doctor standpoint, the farmed Atlantic salmon in the studies that I've seen have the highest omega-3 content compared to the natural instead of the farm. But the farmed Atlantic salmon has one of the highest concentrations of omega-3. That answers his question. I think that he has a good point.
Yep.
It may be a
Well, a lot of it stems from the NIMBY mentality, not my backyard,
Yeah.
which is a whole nother issue that has nothing to do with nutrition, but we can't think of other things to go after the industry. And so the wild salmon industry in Alaska doesn't want farms to be there because it will affect their livelihood. And so they have to come up with these myths that aren't supported by science.
Yep. Before I provide comment, I'd like to open it up. What are some other thoughts on that? You hear it all of the time. Wild is better than fresh. Any other perceptions or thoughts on it?
Do you think a farm fish is less stressed than an environmentally wild fish, and that the nutrition would be different?
That is a very good question.
That's a real question.
Yeah. So the first question: do I think a farm-raised fish is more stressed than
Or less
stress?
Yeah, there's less stress.
Yep.
No, I don't know the answer. I just posed the thought.
No, I think it's an excellent question. I'd love to pose it to the group to get some more thoughts to build. I mean, I'd love to give the black and white answer, but let's approach it from a science standpoint. If you look at the heterozygosity of a farm population, you can maintain more genetics than in the wild, because what is the survival rate of any wild population relative to one that's going to go through a hatchery and then to a farm site? So that makes the question even more complex, because yes, there's a certain amount of stressors, but the feed is being delivered, the survivals are high, and they're expressing higher growth rates than what they would in the wild, right? So the question is that healthy or not?
Or is a less stress producing more growth?
Is less stress producing more growth? It could be, but in aquaculture, we all know when you can find a fish in a hatchery, or even when you have those stunted bluegill, bogging down your pond, there's always stress that's going to be coming. I think that's a really good question that, we probably could spend the rest of the morning talking on that one. Yeah. But I do want to talk a little bit about, the first question on the health status. There are peer-reviewed journal articles that get out there. You really got to look at that data, right? So how big is the body? What are the sample sizes? And really, what are they targeting? Are the implications really the results? Are they inferring something, as you mentioned? In my opinion, fish, regardless if it's wild or fresh, is always wild or farmed, is always going to be better than bacon, right? We all love bacon too. But fish is a great source of lean protein, excellent source of the right balance of amino acids and fatty acids of EPA and DHA. Farm fish, on average, have higher fat levels because they are in an industrial application. Kind of like the comparison is with chicken, right? If you have a free-range chicken and a farm chicken, that back fat on the production chicken is going to be higher because they're really trying to target that fast growth. It's the same in aquaculture, not to the same extent, but the trout and salmon will put on just a little bit more fat than its wild counterpart. But at the end of the day, that fat is very nutritious over some of the saturated fats that we eat through other proteins. And screening for heavy metals and PCBs is pretty standard, right? Because those will bioaccumulate in the animals and affect reproduction. And any other questions? You guys are tough. So, I'll take this one here.
Matt, one of the issues I think that faces pond owners with feeds and nutrition is that they don't want to go out and buy feed every month or every 2 months or every 3 months. They'd rather go buy a whole bunch of it, stick it in their shed and feed their fish all year long. But the problem is that some of that nutrition can break down over time, vitamin C in particular and a number of other nutrients within the food. Are you guys looking at all about trying to make those nutrients, I guess you're looking for stable? Yeah, stable is the word I'm looking for, I guess.
Yep, great question. So the question is around shelf life of products. Before I answer the question, I'd like to give a plug on, we're all biologists and managers here. We need to work with the pond owner. Sorry, I'm from Iowa. The pond's always on the farm, right? So you have to have, when you work with the pond owner, you got to make sure that that feed is in good shape. Never, ever let them feed moldy feed. Don't do it, right? I mean, that is the #1 no-no. Make sure their feed is off the ground, so if they can get a pallet rack or something, get it off the ground, keep the varmints off, keep it out of direct sunlight. Even though it's in a nice bag, you do not want it sitting in direct sunlight. I mean, the worst thing that we can do as managers is let them feed a product that they think is, oh, it'll be okay. No, it won't, right? It may not cause problems the day you feed it, but in a couple months, when you have a fish kill, you may be scratching your head, right? Everything looks pristine. You're the detective trying to look back in time, and you want to make sure that the feed is in good shape. To answer your question, yes, shelf life is one of the parameters that our processing team looks at. We select different types of bags, different processing conditions, different additives that in the feed to prevent microbial breakdown. We have stabilized vitamin C. There's a number of different products that we have to use in the production of fish food that is kind of unique from the other industry, because we have to manage, really delicate fat. And if you don't stabilize that fat, it's going to oxidize. So the answer is shelf life and processing in terms of bag selection and other forms is top priority for us.